guys, welcome back to Wong Chemistry channel. This video is the part 3 video of your Chatelier principle, okay? In this video, we are going to discuss the effect of your pressure and also volume. What will happen to the equilibrium position when you have the changing of pressure or volume? Let's see. Let us recall some memory about what is actually Chatelier principle. As we all know, Chatelier principle stated that if a system that is already at equilibrium subjected to an external stress, or we call it as a disturbance, the system will then adjust itself to re-achieve equilibrium. So what is actually external stress and what is actually disturbance? External stress in our video today will be the pressure and volume, which is the disturbance that will be affecting a system at equilibrium. So right now you already have a system that is already at equilibrium. You already achieve equilibrium, and then we are changing the pressure or the volume of the system. Therefore, the system will then do something. The equilibrium position of the system will then shift in a direction to reduce the effect of the changes. Like we all know, your system will always goes against the disturbance. Alright? So when you have a disturbance, your system will always going against the disturbance to re-achieve the equilibrium or to maintain the equilibrium of the system. Alright? And that is what Chatelier principle is about. And to answer Chatelier principle question, you need 4 things as always. Identify the disturbance. You need to know what will the system do to re-achieve the equilibrium. We know that the system will always go against the disturbance. Okay? And then by using the Chatelier principle, you need to decide your equilibrium position will shift to the left or shift to the right. And as a result, what will be the changes to the concentration of your product and reactant after you have decided your equilibrium position shifting to the left or shifting to the right? Simple. Next, let's look at the relationship between pressure and volume. So, what is the relationship between pressure and volume? As we all learned in your Boyle's law previously, your pressure is inversely proportional with the volume. Alright? So, when the pressure increases, you should know that the volume will automatically decrease. Okay? So, when the question says the disturbance is increasing pressure, we know that it means the volume decrease at the same time. Okay? So, make sure you know that the pressure and the volume are inversely proportional. When the pressure increases, the volume decrease, or vice versa, when the pressure decrease, the volume will be increasing. Okay? So make sure you know the relationship between pressure and volume before you continue watching this video. And as everybody knows, the effect of pressure and volume will be only significant to your gaseous state. You should know that whenever we talk about pressure and volume, we will only look at the gaseous state. Your solid, liquid, aqueous will be ignored in this case, alright? Therefore, when the question asks about pressure or volume, you must actually pay attention to the physical state of your chemical equation. If the physical state is a gas, then we will take count of it. So if everything is gas, then we will take count of everything. But what happens when your chemical equation having solid, liquid, and solid over here? You must remember, when we discuss about pressure and volume, we only look at the gaseous state. Therefore, the solid, liquid will be ignored over here. And we will only take count the gas that you have in the reaction. Okay? And the same thing happened to this equation. Look at it. It's a solid. It's an aqueous in an aqueous. Alright? We know that all this will be ignored if we are talking about pressure or volume. Therefore, in this chemical equation, changing of pressure or changing of volume will not affect the equilibrium position because there is no gaseous state. Alright? So changing of pressure or changing of volume will not change anything in this equation. Make sense? Alright? So please, every single time when the question asks about pressure or volume, you must pay very close attention to only the gaseous state. The solid, liquid, aqueous will be ignored. Alright? Next, what would be the relationship between pressure and number of mole? And bear that in mind, the number of mole that we are talking about is the number of mole of your gas only. So please remember, we are going to ignore your solid, liquid, and aqueous in the effect of pressure. Okay, so we are only looking at the gases. The pressure will be directly proportional with the number of mole of gas, and there is some condition for this directly proportional relationship. Your pressure will be directly proportional with the number of mole of gases with a condition the volume of your container remain constant. Alright, so when the volume is constant in the same container size, you have more gas. When you have more gas, what happens? You will have more collision. When you have more collision, you will then produce more pressure, right? That is the reason why we say when the number of mole of the gas increase, the pressure will increase due to the increasing of collision between the gas particles or between the gas particle and the container. Alright? But with one condition, guys, the volume must remain constant. Alright? And by looking at this example, which side, the left or the right, will have a higher number of mole? Bear that in mind, the left and right is before and after the arrow. That is my left side and that will be my right side. In the other words, that will be my reactant at this moment. And over here will be my product at this moment. Alright? And since we are going to calculate the number of mole of gas, so make sure everything is in gas. And please remember, we will ignore the solid, liquid, and aqueous. So I have 1 mole of gas over here and I have 3 mole of gas over here. So in total, on the left hand side, I will have 4 mole of your gases atom. And on the product, I only have 2 mole of your gases atom, as you can see in the equation. That is my 2 mole, that is my 3 mole, and that is my 1 mole. Okay? So according to this equation, the number of mole gas that is higher is on the left hand side. In the other words, the system will have a higher pressure on the left hand side. Agree? Because the higher the number of mole, the higher pressure the system will produce. Okay? Another example over here, same thing. Make sure you know that the left and right is before and after the arrow. So over here, that is my left side with my reactant. And that is my right side with my product. And since we are going to talk about pressure, and we definitely only take a look at the gas. So everything is in gases right now. This thing is a gas, this is a gas, this is a gas. So what will be the total mole on the reactant? The total mole of gas on the reactant is 1. Okay, it's only 1 mole of gas due to the balance equation coefficient. How many mole of gases do you think is there on the product? I have 1 mole over here. I have 1 mole over here. So I have a total of 2 mole of gases compound on the product side. And based on this equation, which direction will produce higher pressure by the system? And since the total number of mole of gases is higher on the right hand side, in the other words, the system will produce more pressure on the right hand side. So if I want to increase a pressure, the system must move to the right hand side due to the higher number of mole. So for this equation, if the system wanted to increase pressure, alright, then it will shift to the right because on the right, I have higher number of mole of gases. But if the system want to decrease the pressure for this equation, then it will shift to the left. Why it will shift to the left? Because on the left hand side, the number of mole of gases is lower. The number of mole of the gases total in the left hand side is lower. When the number of mole is lower, the pressure produced will also be lower. Okay? So what I'm trying to tell you over here, the higher number of mole of gases or the lower the number of mole of gases is not fixed. It will depend on the chemical equation. It will depend on the reaction that you are doing. So sometimes the product will have a higher number of mole of gases. Sometimes the reactant will have a higher number of mole of gases. So make sure when you have a chemical equation, you check the physical phase and you are going to find the total number of mole of gases on the reactant and also the total number of mole of gases on the product. Okay? So as a conclusion, what will happen when we have disturbance? So if the disturbance right now is pressure increase, bear that in mind, pressure increase also represented by volume decrease. They are inversely proportional. If the question say volume decrease, it will actually means the pressure increase. Okay? So what do you think that the system will do when the disturbance is increasing pressure? Bear that in mind, the system will always go against the disturbance. Remember that? So the system will definitely decrease the pressure. So the question is, how can I decrease the pressure? Simple. We can decrease the pressure by shifting the equilibrium position to a lower number of mole of gases. Remember when you calculate the total number of mole gas on the reactant and product just now? This is the time that we use it. So if the disturbance is increasing pressure, the system will try to go against the disturbance. Okay? So the system will decrease the pressure. When the system wanted to decrease the pressure, what can we do? Simple. The equilibrium position will shift to a lower number of mole of gases. Because when the number of mole of gases decrease, the pressure will also decrease. Remember that? Simple. Next, what would happen when the disturbance is pressure decrease? When the pressure decrease, guys, it also means volume increase. So, the disturbance right now is pressure decrease. What do you think the system will do? Simple. The system will go against the disturbance. So, your system right now will then try to increase the pressure. So, your system will try to increase the pressure. But how can I increase the pressure? Simple. I will shift my equilibrium position to a higher number of mole of gases. Because when the number of mole of gases increase, the pressure also increase. Can you see that? Number of mole and the pressure are directly proportional when the size of the container is constant. Alright? So if the system wanted to increase the pressure, your equilibrium position must always shift to a higher number of mole of gases. Alright? Simple. This is the conclusion of the effect of pressure and volume. Bear that in mind, your system will always go against the disturbance. So, it's very important to know what is the disturbance in your question. Alright? Alright, let's discuss one example after the conclusion that I gave to you just now. The first example that I have right now, consider the following reaction in a container which reach equilibrium at 298 Kelvin. By using the Chatelier principle, state the shift in equilibrium position of the reaction if the volume increases. Guys, volume increases. Okay? So right now, your disturbance is quite obvious. The disturbance given in the question is increase volume. Okay? And we know that we are not going to discuss the volume. We are going to discuss in terms of pressure, which is easier for you. So knowing that the volume is inversely proportional with the pressure, increasing volume represent decrease of pressure. And right now, you already have your disturbance. Your disturbance is decrease the pressure. So what do you think the system will do? The system will increase the pressure. And since the system want to increase the pressure, so if the system want to increase the pressure, we need higher number of mole of gas or lower number of mole of gas. Higher pressure means higher number of mole of gas. Therefore, according to the Chatelier principle, the equilibrium position will shift to higher number of mole of gases. The question right now, the left and the right, which one having higher number of mole of gases? Let's take a quick look over here. So on the reactant, I have a PCl5 which is a gas. I only have 1 mole. So over here, we are having 1 mole of gas. On the product, I have PCl3 which is a gas. I have Cl2 which is also a gas. Having 1 mole, 1 mole. The total of the mole of gases on the right side is 2 mole of gas. Alright? And since right now the disturbance is decrease the pressure, so the system, in order to achieve equilibrium, it will try to increase the pressure. I need a higher pressure, therefore I need a higher number of mole. And which direction giving you higher number of mole? Obviously towards right hand side, because right hand side having 2 mole of your gases, right? Therefore, it will shift from left to right. Okay? This is what will happen. And why we are shifting to the right? Because we have higher number of mole of gases. We need the higher pressure, so we need to move to the higher number of mole of gases. Simple? Easy. So as a result, what would happen to the concentration of your reactant and product? Since we are moving to the product, obviously your product will increase. So your concentration of PCl3 and the concentration of your Cl2 will increase. And vice versa, we are moving from the PCl5. So the concentration of PCl5 as a reactant over here will decrease. Makes sense? Simple. Alright? And that is how pressure affecting the equilibrium position. Alright? Let's try another example. Consider the following reaction is at equilibrium at room temperature. So right now your system is already at equilibrium. Okay? By using the Chatelier principle, state the shift in equilibrium position of the reaction if the pressure applied is higher. And right now, we have identified the disturbance. The disturbance is pressure increase. And what do you think the system will do? Obviously going against the disturbance. So in order to re-achieve equilibrium, the system will definitely decrease the pressure. Alright, I need to decrease the pressure of my system because the pressure is too high right now. Okay, that is what Chatelier said. You need to maintain the equilibrium of the system. So when the pressure is high, we will decrease the pressure. Okay, and to decrease the pressure, your equilibrium position shall shift to a lower number of mole of gases. Why do I need to move to a lower number of mole of gases? Because when the number of mole is lower, the pressure produced is also lower. Exactly what we want. Okay? Because we want to decrease the pressure that is too high right now. And which direction should it go? Should it shift to the left or should the equilibrium position shift to the right? Which one having lower number of mole of gases? Let's see. On the reactant, I have gas. Both of them is 1. It will give rise to a total of 2 mole of gas. Okay? And then over here, you have 2 mole as well. And look at that. Do you realize something wrong? Yes, because both of your product and reactant right now having the same number of mole of gases. So what will happen when the disturbance is increasing pressure to a system that have the same number of mole of gases on the left and on the right? What do you think will happen? Simple. If the number of mole of gases is the same on the left and on the right, changing of pressure or volume will not change the equilibrium position. So, please remember, when the number of mole of the gases is the same on the left and on the right, the changing of pressure or volume as a disturbance will not change the equilibrium position. Okay? The equilibrium position of the system cannot change because both of them having the same number of mole of gas. There is no one having a lower number of mole of gas. So, the changing of pressure will not affect the equilibrium position. It will not affect the system. So, please be extremely careful when you're calculating the number of mole of gas in total for the left-hand side and for the right-hand side. You must always check the physical phase. Make sure you are looking for the gases. And make sure we are calculating the total on the left and also the total on the right. If the total on the left for gases and the total on the right for gases is exactly the same, the effect of pressure or volume will not change the equilibrium position. Okay? Simple. Next example over here. Consider the following reaction at equilibrium at room temperature. By using the Chatelier principle, state the shift in equilibrium position of the reaction if the pressure decrease. So right now, we have a disturbance over here in this question. And the disturbance over here is the pressure decrease. And after so many examples, what happened to the system when the pressure decreased? Very, very simple. the system will always go against the disturbance. Therefore, in order to achieve the equilibrium, the system will increase the pressure. Agree? The system will definitely increase the pressure because right now your disturbance is decreasing the pressure. So your system that is already at equilibrium disturbed by the lowering pressure. So what will the system do? Increase the pressure. Make sense? And how can we increase the pressure? Knowing that when the pressure is high, the number of mole of gases must be also high. Therefore, according to Chatelier principle, the equilibrium position will shift to a higher number of mole of gases. That is what Chatelier principle will do. Alright? We will shift the equilibrium position that will go against the disturbance. Okay? So, as always, when we want a higher number of mole of gases, we need to check your equation on the left and on the right. So, right now, I have my left over here. On the left is a solid, so we will ignore. On the left is a liquid, so we will ignore. Therefore, on the left, I have 0 mole of gas. While on the right hand side over here, take a quick look, I have a solid, we will ignore again. I have a gas with 4 mole, so we will take this one. So, on the right hand side, we will be having 4 mole of your gases atom. So, quite obvious over here guys, 4 mole of gases compound versus 0 mole of gases compound. And we need a higher mole of gases. Therefore, we will then shift from left to right. We will definitely shift from the left to the right due to the higher number of mole of gases that we want to go against the disturbance. Okay? As a result, what will happen to the product? The concentration of H2 will increase. Alright? Definitely increase because we are moving towards the H2. We are producing the H2. Okay? That's why the concentration of your hydrogen gas will increase. Okay? Simple. Easy. Next, and also the last example before we move on to something else. Your example 4 over here. Haber process is a formation of ammonia by reacting hydrogen gas and nitrogen gas as given. So right now, everybody is in gas. Easy question. Because we know that if it's a gas, we will take count of everything. Suggest how can production of ammonia increase. So remember, this is the type of question where you need to suggest disturbance. Okay? You need to suggest disturbance to ensure that your system over here will be producing ammonia. We want to produce ammonia. Okay? And if I want to produce ammonia, my equilibrium position must be shifting from the left to the right because my ammonia is on the right. Agree? So right now, your system must also force the equilibrium position shift from left to right. So the question is, what would be the disturbance that we can apply to ensure that the system will produce ammonia and also the equilibrium position will shift from the left to the right? And how do we answer this type of question? Simple. We need to identify on the right hand side the number of mole of gas is higher or lower. Therefore, let's calculate the total number of mole of gases. On the left hand side over here, I have 1 mole of my nitrogen gas. I have 3 mole of my hydrogen gas. So the total over here is 4 mole of gas. Okay? On the right hand side, we have 2 mole of ammonia gas. Therefore, on the right hand side is a 2 mole of gas. And since ammonia is the one that we are looking for, and ammonia is located on a lower number of mole of gases. So what kind of disturbance do we need to ensure your equilibrium position is shifting to a lower number of mole of gas? Lower number of mole of gas means the pressure is lower. So in what condition will your system shift to a lower number of mole that will produce lower pressure? The system will shift to a lower pressure because the disturbance is increasing the pressure. Can you see the vice versa over here? can you see that your system is always going against your disturbance? So right now, your system is going for the lower pressure because your disturbance is increasing the pressure. Can you see that? And what the question wants is this. We need to suggest disturbance that will result in your system shifting to a certain direction. Okay? Easy? Simple. So these are the only two types of questions that the Chatelier principle question can ask. Whether the question giving you the disturbance or the question asking for disturbance. Okay? Simple? Easy. And for this factor in the Chatelier principle, we have something extra. Let's see what is the extra things in here. We can have addition of inert gas into your system. And we have two conditions when we added in the inert gas. The first one is at constant volume. So when we are adding in inert gas at a constant volume, you need to know that the equilibrium position will not change. In the other words, adding in inert gas at a constant volume will not change anything in your system. Okay? So everything will remain unchanged. So when you have an inert gas added into your system at a constant volume, equilibrium position will remain constant. Okay? And another condition that we can have is when your inert gas is added at a constant pressure. When your inert gas is added at a constant pressure, your equilibrium position will shift to a higher number of mole of gases. So, remember one thing, when your inert gas is added into your system at a constant pressure, your equilibrium position will definitely shift to a higher number of mole of gases. Okay? Alright? So this is the extra things that we have for the factor of pressure or volume in the Chatelier principle, where you can have the addition of inert gas. So we have two conditions for the inert gas to be added into your system. One is the constant volume, which will not change anything. Another one is at constant pressure. When the inert gas is added at constant pressure, the equilibrium position will shift to the higher number of mole of gases. Okay? Let's look at the last example of this video. Consider the following reaction in a container which reached equilibrium at 298 Kelvin. So right now, you'll have your PCl5 in gas, you have your PCl3 in gas, you have your Cl2 in gas. By using the Le Chatelier principle, state that the shift in equilibrium position of the reaction if 0.5 mole of argon gas is added in at two conditions, one at constant pressure, another one at constant volume. So bear that in mind, I hope you know that your argon gas over here is actually your noble gas or your inert gas. Noble gas and inert gas means they will not react with the gases that we have in our system. Okay? So right now, I have my argon gas, which is an inert gas added into my system above. At two different conditions, one at a constant pressure, another one at a constant volume. Remember which one have no changes? Constant volume. If the inert gas is added into the system at constant volume, bear that in mind, the equilibrium position that you have in your system will remain unchanged. Okay? So your equilibrium position won't change if your noble gas is added at a constant volume. How about constant pressure? What will happen to the equilibrium position when your inert gas is added at constant pressure? At constant pressure, the equilibrium position will shift to a higher number of mole of gases. Okay? So right now, the question is, the left is higher number of mole or the right is higher number of mole? So let's see. Before and after the arrow, that is my left hand side. That is my right hand side. Let's calculate the total number of mole of gases that you have. On the left hand side, your PCl5 is 1 mole of gas. So over here, I have 1 mole of gas on the left hand side. While on the right hand side, your PCl3 is 1 mole of gas. Your Cl2 is also 1 mole of gas. As a total on the right hand side, you will then have 2 mole of your gas. And bear that in mind, we want a higher number of mole of gas. So 1 and 2, definitely 2 is higher number of mole of gas. Therefore, you will be shifting from the left to the right in this question. So your equilibrium position will shift from left to right. Okay? See that? Simple. So bear that in mind, addition of inert gas or noble gas, we can have your argon, we can have your neon is also your noble gas, we can have your krypton, all this is your noble gas. So we have two conditions for your inert gas to be added into a system. The first one, constant pressure. So when we have constant pressure, always remember the equilibrium position will go for the higher number of mole of gases. Okay? And then the next one will be even easier. When you have your inert gas added into the system at a constant volume. When the volume is not changing, the equilibrium position will also remain unchanged. Okay? Remember that. And that's it about how pressure or volume can be changing your equilibrium position of a system that is already equilibrium. Okay? So make sure you remember whenever we talk about pressure and volume, we will only look at gaseous compound. So make sure you check the physical phase before you answering the question. Alright? And that's it for this video. If you have any question regarding this factor, drop it in a comment below and I'll get back to you as soon as I can. Thank you for watching and make sure you like the video, subscribe to my channel, and I'll see you again in the next video.
TunePocket.com